Good morning, everyone. My name is Mia Carberry, and I'm here to discuss an important issue that has been impacting our local environment. I am here to present factual and valuable information corresponding to this problem to you, the City Council. The situation at hand is that citizens have reported finding an abnormal amount of fish washing up on our nearby beaches deceased. This has raised concerns in the community about the environment and the safety of the community. I would like to provide clarification to help resolve this matter. In my investigation, I tested water, soil, and fish for various chemicals. I can confirm that these fish are being killed by a certain chemical called rotenone. Rotenone is a naturally occurring poison found in several tropical plant species. This chemical is used extensively as a pesticide. It is also an insecticide and a pesticide. The chemical structure of rotenone is carbon 23, hydrogen 22, oxygen 6. It is composed of functional key groups called ketones. In large quantities, ketones are poisonous to the body. Like I stated before, rotenone is a toxin commonly used as a pesticide, insecticide, and pesticide. Fisheries use this chemical to gain control over the populations of fish species. Trade names for products containing rotenone include chemfish, hubrinol, fish tox, noxfire, and tox-R. For the surrounding aquatic life, the threat of this chemical is minor due to the fact that rotenone degrades quickly from the environment by interacting with heat and light. However, high dosages have the potential to be harmful and hazardous to other organisms. In regards to the community, this chemical does not pose much of a threat because it was only found in fish and in the water. It is important to know that the consumption of fish affected by this chemical is not advised for humans, though it is not entirely harmful. In high amounts, however, this chemical can cause nausea, muscle tremors, seizures, and vomiting. If inhaled in powder or spray form, it is also toxic to humans. I will now address how the environment is affected by this chemical and why fish are so heavily affected by it. In the environment, this chemical does not bioaccumulate. This means that the concentration of this chemical does not build up because it degrades faster than it is absorbed. Mercury is a known example of a substance that does bioaccumulate. Rotenone also does not affect groundwater due to the fact that it barely leaks into the soil. In fish, however, rotenone is non-selective and will kill all fish it contacts. It also affects vertebrae such as plankton and other animals with gills. The gills of the fish are what enables the chemical to enter directly into the bloodstream. This chemical performs as a mitochondrial inhibitor, which negatively affects cellular respiration. It blocks the electron transport chain and stops the production of oxygen. This causes the fish to die of oxygen deprivation anywhere from 30 minutes to a few hours after being exposed. According to Texas Parks and Wildlife Department, all fish are sensitive to rotenone, but some species are more easily killed than others. Gizzard shad and common carp are more sensitive than bluegill and largemouth bass, while channel catfish and bullheads are the most resistant. The advantage of using rotenone is that it allows for selective removal of the target species, and it comes with a low environmental impact. It has been used for centuries by indigenous people in Southeast Asia and South America to harvest fish for human consumption. It has also been used as a commercial pesticide since the 1930s to manage fish populations. Other uses for this chemical include controlling recreational fish populations, killing invasive species of fish, and disease control. Rotenone is well regulated, and for all of these reasons, we still use this chemical today. I hope the information you all have received today was informative and that it clarifies any concerns that you may have. Thank you all for your time and have a good day.